Okay, thanks. Welcome, everyone. It's my pleasure today to introduce Michael Bernstein as our speaker. Michael, I've known since he was a graduate student at MIT with Rob Miller. And there he did a particularly interesting piece of work at the time on Soylent. The idea was to bring people into productivity apps like Word in order to improve the capabilities. He developed a system that in near real time would do a variety of sort of superficial editing passes on Word documents to shorten them, improve the grammar, and the like. And he did a fabulous project that with Jamie and I here at Microsoft Research during a summer, looking at how one could develop answers for Bing using, again, crowd-powered systems. And I think Michael is now a professor at Stanford, where he has a ton of absolutely fabulous students, many of whom we've had the pleasure of hosting. And I really think of him as one of the leaders in thinking about hybrid computational systems that are made up of both human and algorithmic components. And today what he's going to do is really take a step back from that and think about the topic of crowds computation and the future of work, but do so in a way that really is more flexible than some of the early attempts, and one that tries to encompass some of the fragility of the earlier approaches in doing this. So have at it, Michael.
Thank you, sir. Yeah, and I do have to say, I have to give a lot of credit to Microsoft Research through my 2 internships here in helping me set the direction that I've been following. I was doing personal information management research in the master's part of my graduate degree, and came here, worked with Mary, Eric, and Desney, and ended up pivoting essentially into the social computing space, where I've landed ever since. So really formative work here. So yeah, the topic today has been sort of an evolution of my thinking over the past few years, really zooming out and asking at the highest level how large groups of people, or even small groups of people, anyone, can work together to achieve whatever goal they set out for themselves. How and in what way can computation amplify our collective achievements? I think it's not really a surprise if I were to argue that anything from a small team to a massive crowd, you have these groups coming together to work on some of the most hard and challenging and important problems. It doesn't matter whether you're designing an operating system or running an organization or creating an organization that's designing an operating system. Like, you are really bringing together huge groups of people. And I think one of the silent questions that every such group has to face is how we design our interactions. There's this multiplicity of possible designs that any group has, and how our members are going to interact, how we're going to coordinate, how we're going to socialize, how we're going to make decisions, everything else. And in this group, we have basically as many opinions on answers to this question as essentially there are people. And we know from both personal experience and literature that making the right decisions here is really critical, because poor decisions lead to fraught interactions like fights at best, and outright dissolution and fracture in the worst case. And so we're sitting here, we have to make these decisions about how we're going to interact to get anything done, or to get done the most challenging things that we want to achieve. And yet, what the literature suggests is that we're actually pretty terrible at making these decisions. Here's a field, it's called organizational behavior, telling us repeatedly and over the last 50 years just how bad we are at designing these interactions. This is essentially saying things like, we're very good at splitting up work, but very bad at foreseeing how hard it's going to be to basically pull it all back together again. Think of any group project you had in college. Or we underestimate the declining efficiency of adding scale to the groups that we're working in. There's just an entire literature across many disciplines, here's just one, that really makes this point with force. And essentially, if I were to abstract away, my point of view on this is that it's telling us that we're ill-equipped to choose between these designs, that just like we have cognitive biases and heuristics that operate at an individual level that influence our judgment, so too is it really difficult for us to make decisions about how to aggregate lots of people's interactions together into a desired emergent outcome. And I think that challenge of designing for emergence is really the fundamental challenge of social computing design. All we can do is control how maybe dyadically or small groups would interact, and we want to create some sort of emergent, stable outcome. And this has been a challenge. But I do have some hope here, and I think it wouldn't be surprising anyone in this room that the source of the hope is that increasingly these kinds of interactions are happening mediated through computation. And I think for me, where this started out was through crowdsourcing systems, but increasingly we're seeing everything through collaboration tools, not just that, but also the crowdsourcing markets, social network sites, all providing an opportunity to essentially inject computational mediation into those interactions. So just like as an HCI designer, I might try to design an individual's interaction with computation, so too by designing this computational layer, can I have potentially some influence on how that group interacts. And I think doing this can shed light on some really fundamental questions about group behavior. Largely, I will take a sort of systems design or HCI design angle on this. There are some folks like Sid and others in this room who have done some really foundational work on the social scientific lens. So I think these two come together. But we have this huge opportunity, right, of computationally mediated interaction. We can design these interactions. And I think it's fair to say that as a field, we've directed this huge potential into something that looks like this, microtask labeling. And it feels like a bit like we're not achieving what we have the opportunity to. And I'm starting here in part because it's my own story. Like, people are, in this case, labeling when there's a person on a motorcycle. But I think that I want to sort of take an arc that will push things forward. So this is really powerful. ImageNet was built this way. Many other really foundational pieces of work come out of this kind of data labeling and annotation. But it seems like it's not really taking a lot of the human component into consideration. Just to give a very simple example, without trying to break the paradigm, what if we acknowledge that essentially people are very risk averse on these platforms because they're afraid of what happens if they get stuff wrong, and we say, what if we just make it okay to screw up a bit more? And in fact, what if we encourage you to screw up? So here's a little bit of participation of the folks in the room. Hold up your hands. Clap whenever you see a man riding a motorcycle. You ready to go? Here we go. You're about as accurate as everyone else I've tried this on. So you'll notice that you make errors and you're delayed. And my point of view is that that's fine, that's okay. Zone out with it. And it turns out that we can, by randomizing the order in which we show these images to different people, we can model those errors and the delay and essentially get at the same precision, like an order of magnitude more data labeled, without increasing people's levels of mental workload. So we can start to understand the human element of it and start to do better. We can start to build systems like my student Nilafar Salehi, who's now at Berkeley, supporting collective action for crowd workers. What does the future of the gig economy mean for collective action and how workers essentially assert their rights? Building out visions that would support like education, micro-internships so that you can learn new skills, collective accreditation so that workers themselves can essentially help articulate and certify people as being high quality. Or even pull together, replace the sort of microtask workers with on-demand experts and build tools that would support on-demand expert teams. This is a project called Flash Teams, where we're bringing together directors, animators, scriptwriters, illustrators, and so on, following similar kinds of workflows, in this case to create entire short animated videos in 24 hours. This is actually a video of Terry Winograd, who founded the HCI group at Stanford, building a computer in his garage when he was a kid. I don't know if he actually looked like that when he was a kid, but that's how I imagine it. Now, as we were doing all of this work, something kept nagging at me, which is there's a sort of approach that has underpinned a lot of my work and others' work in this space that's basically algorithmic. There's a sort of von Neumann architecture of crowdsourcing systems where you're modularizing and predefining all of the work that gets done. Amy Edmondson at Harvard calls this situations where you have high process knowledge. Essentially, it looks a lot like this, where you have boxes and arrows. Their workflows is another word for it, where you take the big goal, you split it up into a lot of smaller tasks, and then computation can help sort of algorithmically control who's doing what, when, and so on, and then weave it all back together. And this has really been, as I said, underpinning a lot of the approaches I was just showing and many other ones. And it's been undeniably powerful and led to probably about 10 years of research at this point. But increasingly, we're starting to see the limits of it. we have these goals like invention, production, software engineering, and other things that, despite a lot of research in it, has more or less remained out of reach. Like, we don't seem to have these kinds of workflow algorithmic approaches for those kinds of tasks. And after digging around a lot, it's actually should have been obvious that these open-ended and complex goals actually are essentially fundamentally incompatible with any kind of requirement to modularize and predefine behavior. So it doesn't matter which theoretical background you're coming from, whether you call this a wicked problem or something involving situated action or a reflective practitioner or requiring reciprocal interdependence. That's like 5 different literatures right there. They all basically make the same point, that you cannot from the beginning predict all of the possible eventualities and essentially design a workflow that can account for them. These are situations wherein you have low process knowledge. And in fact, this has been pointed out really early on. So Yochai Benkler, who talks a lot about peer production system, points out that peer production is limited not by complexity, but by modularity, how well you can sort of split things up. And Linus Torvalds, who basically created the Linux operating system or kernel, talks about how with the kernel they needed a system that was as modular as possible. And you even have Topcoder talking about how essentially they're advertising how they atomize projects. This is basically a limit not just in the research world, but also in things that are really happening. And I think this is in part, if I were to guess, a reason why open source software is better at replicating known software, because we can basically take it and we know what we're trying to do and modularize. So the irony that I sort of want to try and point out that I want to get toward is that this architecture is confining these collaborations to goals that are so predictable that they can be entirely modularized and predefined. So it's power, but it's also a limit. And in this talk, essentially, I want to demonstrate at least some preliminary evidence for an alternative approach, which is collaboration structured not algorithmically, but as essentially computationally augmented organizations. And I would hope to show that this is both more powerful and also much more humane. I'll do this through a series of 3 projects, Flash organizations, Dream Team, and Crowd Research, that are trying to push on different elements of this thesis. So I'm going to start with Flash organizations, which is work that I would especially point out was co-led with Melissa Valentine and Daniela Ratelny at Stanford, along with another party of really great collaborators. Essentially, if you're going to take anything out of this, what I want to push is a view of these Flash organizations as rapidly assembled, reconfigurable organizations that are comprised, in this case, of online collaborators. So sort of schematically, rather than something that looks like this, we're looking at something that looks much more like this, except that there's probably a computer doing some really heavy lifting in the middle. And what I hope to point out is how computation can afford these really rapid modes of coordinated adaptation, as it's known in the organizational behavior literature. And to cut to the chase, the way I'm going to demonstrate that is to show that these Flash organizations are able to carry out very open-ended complex goals that were previously out of reach for crowdsourcing. Things like product design, software development, and game production. And underpinning all of that, I'll be talking about a software platform we've been building called Foundry, which is a place where people can essentially author these Flash organizations, reconfigure them, and then essentially help manage them as they go. So if you were an organizations scholar at this point, you'd tell me that what I'm saying is crazy. And the reason is that organizations rely on something known as asset specificity. That is, that people get to know each other. And organizations work because people know what they can expect of others and how to coordinate and how to interact and all these kinds of things. And I'm essentially pitching this world in which that might not exist. So we're going to draw on a set of basically theories from what are known as temporary organizations. These are organizations like film crews, disaster response teams, and so on, medical, like hospital ER teams that are able to coordinate despite not necessarily knowing each other really well a priori. And the way they do that is through what are known as role structures. Role structures essentially enable people to interact based on their knowledge of how the roles are supposed to interact instead of the roles of how individuals are supposed to interact. So let's say Mary is directing a movie. So she's like the director of the next Harry Potter movie, and I'm a gaffer on that movie. She may not know me, and I may not know her, but she knows what to expect from gaffers. And I know, as a gaffer, what to expect a director should be asking of me. Essentially, this is the intuition behind how role structures work. And we're going to design the entire platform around that kind of coordination, where we're focusing on roles, where essentially you can identify kinds of expertise and ways that people should be interacting, like we need Android developers or graphic designers or people who can do user testing. We nest these roles into teams. Those teams are again nested into a hierarchy to support coordinated adaptation. When you have this, it allows the system to essentially do some stuff that's relatively smart. For example, as soon as it identifies the need for a new role, it can reach out to a large group of possibly qualified individuals. In our case, we're using Upwork, but in principle, it could be any source of volunteers or paid laborers to essentially bring in individuals, and then also to help onboard individuals. So because this entire sort of source code of the organization is known to the computational system, it can say, here's where you sit, here are the tasks that are sort of feeding into yours, here's what's dependent on you, and so on, and help bring people together. Now, again, if you were an organizational scholar, you'd say, well, this still shouldn't work. The reason is that organizational structures succeed because they can get reconfigured all the time. Despite sort of the popular press attitude that organizations are very static, et cetera, in reality, organizational structures are very flexible, and that's why they work. So how does such a system actually keep this distributed set of people in sync as the plan is evolving? And to do this, we draw on a metaphor essentially from version control, where the idea is that essentially you have everything, the tasks, the teams, the hierarchy, as the source code of this organization, and then allow anyone in the organization, bottom up or top down, to essentially branch these organizational structures, suggest changes, for example, maybe bringing in a new role or saying that we're going to need more time on something, and then merge that back in. So in particular, in the system, the way this looks is that any member of the organization can create a branch, which is essentially a copy of the organization that's tied back to a particular point in time, make any edits like deleting this, adding people, and so on, and then issue a pull request that goes somewhere up the hierarchy, and if agreed to, can be merged in automatically through a three-way diff. And without going too much more into the details of how all of this works, I want to at least give a high-level sense that this makes sense. So I'm trying to make an existence claim here. I'm not trying to necessarily claim that this is better than any other way of organizing, but I am trying to claim that it is possible to achieve really complex goals through this mechanism where previously we've seen it to be impossible, or at least we have not observed this to be readily feasible. So we basically ran 3 Flash organizations. We recruited people who had no expertise in crowdsourcing, for example. One of them was a medical resident who wanted to build a prototype Android application and large display in a hospital. You might be surprised to find out that hospitals don't actually know who's en route in the ambulance until they arrive. So the idea behind this was they wanted to build and prototype an application that would allow the EMTs to sort of report the trauma cases en route to the hospitals. Second, this system was a Kickstarter-backed storytelling team that wanted to essentially design and manufacture an in-person board game. This was a group that wanted to basically do something like Cards Against Humanity, but for storytelling and for humanity. The idea would be that they would have a series of cards, and you would pick a card, and everyone in the room would tell a story on that theme, and then the group would, I think, vote to pick which of the stories was best, and that person would get points, and so on. And third was we connected with Accenture, who wanted to basically build a workshop planning portal for their client engagements. So these ranged from very tiny groups to huge organizations. And what we found, and I'll give a little bit more detail on this in a minute, but just to sort of cut to the chase, these end users without previous experience were able to spin up and lead these entire organizations in about 6 weeks from start to finish, convening new folks on demand within about 15 minutes. So they went from nothing to completed projects within about a month and a half. And what I mean is that they built 2 mobile applications, 3 full-stack web apps of about 50,000 lines of code, 2 illustrated card decks, across hundreds of tasks, hundreds of pull requests, about 3,000 person-hours of work across everything from engineers to poets. And all of these things were later reviewed by neutral experts just to make sure that they were achieving their quality bounds. So just to sort of understand what that looked like, you had this individual who had no experience in mobile app development, basically starting off by themselves and then over time sort of accreting an organization by hiring people who knew about Android development, user interface design, front-end and back-end development, user testing. You can see the timeline along the bottom. They eventually built out an entire marketing team to help build out a website and a video to sort of explain the thing. Again, from 0 to 60 very quickly. At the end of it, they had produced something that looks like this. The dark blue screens are the tablet application that they had built. On the right is the accompanying large screen display that was intended to go in the hospitals. And you can see the video that this marketing team ended up creating to sort of explain the idea. This True Story team, true to form, prototyped, play tested, and iterated on a game based entirely on this remote collaboration. So they, most amusingly to me, convened this entire team of poets to write the prompts for each card. So this was a card that was supposed to like get you to essentially tell a story about a crush you had at some point. This sort of amusingly led to the creation of a position of a chief poetry officer, who was responsible for coordinating all of the poems and having a consistent sort of language and attitude to them. This was a great. This project was a really good example, actually, of sort of rapid adaptation, where a week before the finish, they decided, hey, wouldn't it be cool if we had an accompanying mobile application that would allow the players to record the stories and then upload them to the cloud so they could listen to them later and laugh at their friends? So they spun up an entire mobile app development team in that last week to build a prototype application that they could play with. The collaboration with Accenture looked very organization-y. You can see that it had a lot of strong branding. It had to go through sort of internal review from on the Accenture side. This was the largest sort of software project that was built. That they built out basically an entire engineering team from scratch to tackle this project. Now, if this were to become a long-term product, would you use this? I would claim probably not, as eventually this would accrete into something that would look a lot more like a traditional product team. But for a rapid exploration, it was really interesting how quickly this could get spun up. So here are my reflections on this project. First, it sort of suggests a bit of a different point of view on what organizations can and might be. One in which organizations are fluidly assembled and adapted within a globally networked collective. If you just take the most simple point of view, Microsoft itself is a large collective of really talented experts. And rather than simply saying, here's the organizational structure, if Microsoft were to say, well, how do we convene the right people for the right project at the right time, you might start to think of essentially computationally powered approaches that might in some ways resemble this or might look different. And I think that there's a real power in that. Now, I think there are a lot of open questions, some of which we're exploring now. One, I basically ignored the data science of organization structures here. But there's a huge opportunity as you get more and more data about essentially which organizational structures help people collaborate effectively, where they're happy in the environment, where they're achieving their goals, and so on. You don't have to do this from scratch, right? We can suggest motifs, so to speak. Likewise, I think it's important, as I was indicating earlier, as we create these new modes of production, to think about how we support industry norms, labor organization, and legislation to encourage a pro-social future of work. And I think on the design side, this is important to essentially set norms, what's expected. And I think on the legislation side, I think that's what's important to avoid the possible negative outcomes, because designs can always be overridden by a negative actor. So at a more academic level, something that we're still wrestling with was the ways in which this might change transaction costs. So if you're familiar with Coase's transaction cost theory, essentially it argues why do firms or organizations look the way that they do? Why do they hire some people in permanently? Why are some people hired sort of ad hoc through markets? And the answer is essentially these things called transaction costs, which don't literally necessarily mean money, but could be effort. And as these kinds of techniques lower the search and bargaining transaction costs, my hunch is that it might start to change the sort of permeability or the boundaries of what an organization might look like or a team might look like. Can
you reflect on the examples you just gave? Did some structure develop? So was there a leader or a set of leaders, or did those get handed off throughout the...
Yeah, so here's one of the examples. So the guy who started it was still sort of up top. And there were leaders of individual teams. That proved necessary. Like once you hit a certain scale, there's value in hierarchical organizational structures in terms of having centralized points of communication and so on. But the three organizations all looked very different. So actually that's what the organizational behavior literature would predict is that these structures get customized to the organizational context. So the true story one was very flat, and the sorry, I'm trying not to generalize, but the Accenture one was very hierarchical, and I would argue that that was basically due to the management style of the person who was in charge and the organizational context that they were created in. Yeah.
Stop this from like spinning out of control. Like essentially everyone can just create a branch, right? So who's monitoring like progress?
So the branches, essentially don't become reified until the pull requests get merged. So it has to get approved by someone up the chain. So essentially that's what sort of keeps things in sync. Eventually, if let's say that I have an idea, Jamie says, yeah, whatever, but like you're in charge of the two of us, and you say, what's going on? You would basically enforce a top-down swap back to whatever norm you'd want. So I could put myself in charge of the organization, and you'd probably be like, no, probably not. That's basically what keeps it in sync. But I mean, as a social computing designer, I should lay out maybe one of my assumptions. Any social computing system can fall over, and it also can succeed. And I think that depends on how you set the norms, how they're enforced, and so on. I think, so in some sense, academically, it's less interesting to say that something could happen. And the question that I think you're asking, which is slightly more interesting, is essentially one of like, what are the likely norms that would develop, and what issues might fall out of that?
Yeah, one thing that I'm recognizing is that if the hierarchy goes deep, then it's maybe not effective to have the branching structure possible at all levels, right? Because only lower levels can really accommodate branching, and then those can be like merged.
Yeah, I mean, I think the upper levels, as you probably observe here at Microsoft, do occasionally branch, i.e. reorg. Like that can happen. I think that most of these organizations were at the scale of like 30-ish, and I think at that scale it made sense. Most of the changes were local, and I think that's appropriate. Yeah. That we're teaming, as Amy Edmondson calls it. We're sort of ad hoc, keeping track of local things that are going on, or sort of small local collaborations. But yeah, I think it's the role of people further up the hierarchy to essentially be keeping tabs on the higher level structures, and that's in fact, like according to organizational theory, that's their role. Like essentially, information percolates up, and so that this individual has the information needed to make an intelligent decision. That's the goal. Now, you could disagree with whether organizational structures are the right way to go. I'm not pitching for hierarchical like management here, other than to say it's something that I think is far more flexible, and in some ways, in other ways, more effective than these sort of predefined workflows. There was a comment there, and then I'll swing around to Adam. Yeah.
Did you study how the incentive structures for the workers worked out? Like, I'm curious. Like, do people in very adaptive Flash organizations suddenly feel like they are one of many possible people who could have fitted that role, and so what's the unique thing they're bringing in?
Sure. So I should start by saying what the incentive structures were, because I didn't actually describe that. We were using Upwork, which is, for those of you who don't know, basically an online labor marketplace where you can find experts and anything that is on this chart and many others. And we paid people their hourly rate. So essentially, the wages tended to be in sort of anywhere from like the $30 to $100 an hour range. Thanks to sponsors, including Microsoft, for helping support this research. We were most interested in sort of the coordination questions around this. So we were explicitly not asking questions around incentive structures. There's a lot of work in that space that I think can be very directly applied, and questions that could be asked. Just as a simple example, often you want to have an incentive structure that both incentivizes sort of the individual outcome and the group outcome, right? Because if you do just one or the other, things go poorly. But I don't think these are new questions that we've introduced here. Yeah, Adam.
Yeah. So these are really very impressive examples of sort of product incubation. I was wondering if if you've looked sort of longer term at, for example, maintenance and sort of support costs, those might be cases one might argue that have more dependence on like institutional knowledge as to why these decisions were made.
Yeah. So and I think you can see cases of this going in both directions in, say, like open source projects where there's turnover and so on. Yeah, my claim, and I will state it as a claim because it's essentially untested as far as I can tell, at least within this context, is that this is a very effective mechanism for sort of rapid exploration and adaptation, sort of in these early stages where you're trying to get a handle on your idea. But if you're looking for something that's like maintenance, QA, and so on, even though there was a QA, like a large QA team, you're probably looking for something that's a bit more stable, because at that point you can predict more effectively what the needs are. So that makes sense. One interesting thing I would counter with, though, is that this number of roles is not exactly, well, we flattened it here so that I think it's roughly equal to the total number of people in the organization. But what actually happened was much more fluid, where people would weave their way through different roles in the organization. So I start out over here. Once that need finishes and there's a more pressing need here, I shift over there. So in many ways, you actually have this organizational memory, this institutional memory, but it's not through the roles. It is sort of through the people a little bit. In a separate project that Nilüfer Salehi was working on, we were looking at ways in which we could convene teams that are both sort of rapidly available, but also balance that against familiarity, so that you could bring together people who we were trying to bring together people who had worked together because of the asset specificity, and they knew how to work together well, but you could also balance that against people who have the institutional knowledge on the project. So I think there's lots of opportunities. Yes, Steve?
Yes, I know this is something you optimize for, but since you brought up cost,
yeah,
how does this compare cost effectively versus some sort of more conventional design team allocated specifically to a task?
Good question. In order to answer that, we would probably need to be asking, I feel like the fairest way to ask this question, let me back up. The direct way to measure this is not necessarily what I would view as the right way to measure it, is to say you have this approach and then you have sort of like an internal team. And Accenture actually did some of those comparisons, because they're like, we know how much hourly our own employees cost, and we know how much these Upwork employees cost. But from my point of view, that's basically just leveraging labor, like wage arbitrage. Like, these people are cheaper, and like I feel weird about that. It doesn't feel like right. Instead, I would probably be asking questions of like, which coordination mechanism is the most effective way, right? So you bring together sort of like a traditional project team and you manage them in the traditional way, or you bring together the same sample from the same group of people and coordinate them in this way. And that's the study I actually want to run, is whether this sort of computationally powered coordination mechanism is actually, what its effect is on effectiveness, on satisfaction, and so on. That's where I want to go. I suspect that there will be some process costs, but maybe bring other benefits. Yeah. So then let me touch on where this sort of train of thought led me. This is a project called Dream Team, led by my PhD student Sharon Zhou, along with, again, Melissa Valentine. Because as we moved from this sort of algorithmic crowdsourcing approach to something that was effectively more team and organizationally bound, the question essentially stares us in the face, is like, what's the best way to organize a team? I think this calls back to a lot of very traditional CSCW literature in many ways. And again, not just these Flash organizations, but every organization relies on teaming and ad hoc collaboration. That's sort of the best way to do effectively, especially things that don't have high process knowledge. And so you're faced with these questions. Are the teams supposed to be flat or hierarchical? Should we be encouraging, like I'm overly encouraging sometimes, or critical, like some nega version of Michael Bernstein, enforcing equal turn taking, or what? And I'm just going to sort of pull those all together into what the literature calls team structures. Again, think of these as sort of the source code of a team, right? The roles, norms, and interaction patterns are these team structures. And there's a large set of literature, including in CSCW, that's theorizing ideal team structures, building systems to nudge toward those effective structures, and so on. So we in HCI and CSCW have a history of thinking about these kinds of issues. But But unfortunately, at least for me, this question of what's the best way to organize is actually ill-formed. The organizational behavior literature, and in particular something known as structural contingency theory, basically points out that there is no single set of ideal structures. That like all of these arguments we have in Harvard Business Review or whatever about like, let's do it this way, now let's be holacracy, now let's be this thing, like basically don't make sense. And in particular, it depends on the task and the people. So it's just contingent, right? It depends on the people and what they're trying to do. Unfortunately, the wrong structures, what the literature shows, will doom these teams to dysfunction. So you pick the wrong structures and it doesn't go very well. And actually, before I unveil this next point, is anyone here like a PM or have an MBA? Okay. So then I'll state that it turns out that managers, the people who are paying a lot of money and are paid a lot of money to do this, are actually not very effective at it either. And again, I don't view this as like, it's not a dig at MBAs. There are some very, very smart MBAs. It's just that it's a very hard problem space to reason about. So our vision with Dream Team was to allow teams to rapidly self-experiment with different team structures in order to converge on one that works really well for that set of people on the thing they're trying to do. So essentially, it's you have people come in to our system, and the system colors them with a specific set of team structures that make sense for them. Different teams comes in, they have a different set of structures. Different team comes in, and we have this colorful panoply of different teams. We built this into Slack, so just to give a sense, the idea would be that the team comes into Slack to come have a collaboration. We give them some sort of task, right? So in this case, and I'm going to introduce this now because eventually we're going to use it for our evaluation, they're solving a really complex collaborative puzzle. So they're working together on this puzzle, and at the end of the puzzle round, they give some sort of feedback to the system. Now this might be either performance-based, or it could be subjective feedback based on the members of the team. And based on that feedback, the system actually nudges. It suggests, hey, you know what, this sounds a little silly, but try actually shifting sort of the norm of how cheery you are. Just be a little bit overly cheery right now. Let's give it a shot and let's see how it goes. And this continues. There are a lot of different team structures out there. Based on a review of the literature, here's a few dimensions. There are hundreds of combinations just of these. Essentially, the way that Dream Team works is that you start out with sort of neutral or emergent norms. Based on the feedback you give on how that's going, the system starts exploring and suggests, well, here, maybe you should try a decentralized hierarchy. You give feedback again, and over time, the system is essentially evolving the team structures to identify the right fit. Now, if this may be starting to sound familiar, it's basically using a network of multi-armed bandits under the hood. And we tried that, and it didn't go so well. The reason being that essentially you have this network of bandits, each of which is trying to manage its own explore-exploit trade-off, which basically means they're all exploring at the beginning. So imagine it's like you're sitting with your PhD advisor, and they give you like 30 pieces of advice, and you don't know which one to follow, and you basically ignore them. That's basically what happens. So it's like rather than you start with one set of structures and it says change everything, and people get lost. So we ended up developing a new model of bandit that we call a temporally constrained bandit that basically would directly model when the teams are open to change and to how much change they're open to at once. For example, we know from the literature that teams are most open to change at the midpoint of their progress. So we model this through a very straight, there's a very small grammar of sets of options here. So here, you want to have the most changes near the middle. And then other kinds of dimensions, we know people are resilient to change at the beginning or at the end. So teams are resilient to exploring hierarchical structures early on, but surprisingly, actually to me, really open to it later on. So you can have dimensions that can either be changed early but not late, or vice versa, or okay at any point. And then what we need to do is essentially try to take this information to calm down how many suggestions this network of bandits is giving. And we're going to do this by basically redistributing this probability of arm selection. If you're familiar with bandits, it does this thing called Thompson sampling, which roughly works by you end up with a posterior probability of how much you should be you're certain that arm is the right one, like being hierarchical or decentralized or whatever. And you sample just directly out of that. So you have a 0.4 probability of the next round sampling that first arm, et cetera, et cetera. So what we want to do is basically cool it and say we want to stick with make it more likely that we stick with the existing arm, say essentially reducing the probability of exploration to about a quarter of what it would have otherwise been. That's our goal. And we do that by basically slicing off some of the weight from the other arms. There's a formulation for how we do this, but essentially this is the intuition where we know what we're trying to get to, say maybe just reduce the exploration to a quarter of what it otherwise would have been, and then we can redistribute that probability from the other arms onto it. And we can do this in parallel across all of the bandit arms. And what that results in is an ability for us to place essentially a global constraint on the expected number of simultaneous changes. We say, in expectation, you should be doing no more than 2 changes at once. A global constraint on the expected number of changes, and also to prioritize which dimensions can change when, right? Some things can change early or late. How do we prioritize? And as we do this, we sought to evaluate whether this would actually be helpful. So we pulled together a lot of folks off of Amazon Mechanical Turk, randomized them into teams. So these were teams that were virtual teams. They were not working in a co-located way, and they hadn't worked together before. So that's a limit on this analysis. And the measure that we cared about here first was the performance. So how was the team doing on this really hard puzzle task, which we derived it's actually surprisingly challenging to derive a performance score that can't easily be Googled. So we had a system that would generate puzzles automatically. If you've ever played Code Words, it's a game where people are trying to guess words. We used a system we had built previously called Empath to generate a bunch of different game boards and used that. So the groups had a training round, a round to sort of so the first round, they learned how the game works. Second round, there were no interventions. And then 10 rounds wherein the system might be giving them nudges. There were 5 conditions, 3 of which were human. So in one case, they had managers who would decide which team structures. Now try this. Now try this. We gave them the full list of options, and they were able to explore. The second option, it was collectively chosen. So the group would decide together. Now let's try this. Now let's try that, these structures. Third was a control round, or a control condition, where we didn't say anything. I think we gave them the set of the same information, but didn't enforce that anyone had power to make those changes. And then 2 algorithmic conditions. In one case, the sort of straightforward network of bandits, and in the other case, what I was just describing with these temporally constrained bandits. What we found was a more striking effect than I was expecting, which was that these Dream Team teams outperformed the other conditions by about 40%. Now, if we were to try this in multiple contexts with lots of other teams, would the effect size be 40%? I'm actually sincerely hoping not, but let's unpack this for a moment.
Did you say that the control was better than all the other ones?
These were all statistically indistinguishable from each other. Okay. So, in fact, the only condition that was statistically distinguishable from any of the other ones was the Dream Team condition, and it outperformed all of the other ones. So Dream Team outperformed all the other conditions. The other conditions were basically all noise relative to each other. So if you unpack essentially what happened here, if you're familiar with prospect theory, basically what happens is that the individuals were risk averse. So even when there was a manager, it turned out 2 or 3 different configurations, and then basically said this seems good enough, and they stuck with it. And on the other hand, when you had this unconstrained bandit system, it was just going nuts and suggesting too many changes. And in most cases, the teams just sort of started ignoring it, which is, again, not a surprising outcome. And it was sort of a Goldilocks principle here where this system was encouraging enough exploration, more so than people would do otherwise, but not so much that people get lost. And they stuck with it and wound up with this performance change. So I think my takeaways from this are essentially that we wind up with these team structures. If we're using sort of our internal cognition to think about this, we tend to do so in a slightly risk-averse way. Algorithms can compensate, but they sometimes will overcompensate. So it is really this sort of like human-driven design that really gets us where we need to go. I think open questions. One, I think this system could be used by a negative actor to basically try and maximize performance to the exclusion of like happiness. Now, my personal view is that ultimately that would probably undermine performance as well, but I think there's a lot of gray area in between where people are pretty unhappy, but you're not seeing it. And I think that it's important to ask what are the right ways to combine feedback equitably in these systems? Should everyone's voices matter equally? If not, who should matter more and why? Should performance matter or not? And then these open questions. As I said, if membership changes or task changes, like essentially the structures need to change. So how does the system sort of adapt or reinitialize when there have been changes? Because teams go through different kinds of phases in which they're doing different things. And I think also, looking at these longitudinally within a traditional organizational context would ask additional kinds of questions as well. So I'll pause here with Dream Team for other kinds of feedback. Yeah.
Did you break out compliance and number of changes, as in where there's some, like, did the people actually comply with the suggestions the Dream Team was making more often?
Right. We did that analysis qualitatively, but we didn't do any structured coding on it. In part because there's a lot of gray areas where the team might be hard to tell. I can tell you from the qualitative evidence, it seemed very strongly and very clear that in the unconstrained bandits, it was just sort of like laughed at in many cases and just ignored. In the human-driven conditions, I think because there was a little more buy-in, it was more likely. We didn't force any of these. So from a conservative point of view, this should be on the weak end of the effect size, right? Because if it were forced, then you would see it happening more. My sense was that most of the time they were doing it. Now that could have been because they were part of an experiment, there were novelty effects. We never explicitly made their payment contingent on this, but there's always these demand characteristics, right? So I suspect that's at least part of it. And I think that if you were to get a long-term engagement, you would need, the buy-in is really critical. So how do you build trust in such a system? Yeah, Jamie, then Sue.
Just that actually made me think also about, do you have any thoughts on how bias, human level bias, gets either captured or avoided in processes?
I think, so bias could be easily encoded through the feedback. So if you're taking, subjective, say Likert style feedback, and let's say you have, 9 people on the team who are all from group A and 1 person from group B, there's certainly going to be a tyranny of the majority there, right? And I think that's all about, there's all this discussion about, equitable machine learning and transparency and fairness and so on. I think if you ask, how do you craft that reward function, that's a deep question I think this is going to come up even more in the project I'm going to talk about in a moment. So I have more well-formed thoughts there, but certainly, yes, it could happen. Yes, Sue?
You sort of alluded to my question in the last bullet, and especially if you're thinking about it from a Bandits perspective, it seems like you assume a stationarity over time. And what if there are different sort of microstructures that are relevant for different points in time?
Right. So
I don't know how long this task was, whether you can make that assumption here, but it certainly seems like things are very different in an early brainstorming phase than when you need to deal with compliance later.
I think as a future work direction, the important thing to do is to effectively say, can we build a classifier that says, whoa, things have changed? When are the right times to sort of restart? Just to restate the question, we're making a stationary distribution assumption because that's what bandits do.
Right.
So within the constraints of the exploration, we assume nothing changes. But for example, in a longer term, people learn how to be better team members, right? And I suspect, so there's the deep, bandit question of how do you design bandits that don't assume stationary distribution. But I think more directly, I suspect that just understanding what's the tempo of these changes and what kind of triggers can we attend to is the right way to go. Yes, Sid?
Just a very low-level question. You said you had 45 teams, 5 treatments, so you had 9 teams per treatment?
I believe so, yes.
Okay. Good.
Yeah, so it was in terms of the power of the study, it was, it's possible that you would see some internal changes if we had a higher powered study between these groups, but
I'm not so worried about that. I'm worried about the 40% at the top.
What's the point estimate? Yeah, I can go dig into that a bit.
I believe you that there's not huge effects to be had for these other 4. But.
Yeah, I mean, if for a moment, if I were to just sort of back of the envelope this and suggest that it looks like we have something like a 5% change within these conditions, and if we say that, that could be fully random, then you could, I think you'd still wind up with a fairly large effect size, at least by effect size measures. I don't think you're going to pull it down to 5%, but my sense is that, like, honestly, my worry is not specifically about the number, just that because I don't actually expect the number to hold up if we were to do this in, say here at Microsoft. Like, I think that hoping for a 40% effect seems unreasonable. So my take on it is more, why did this work when these didn't? Or at least why did that have a larger delta? Yeah, I can go back and look at what our 95% confidence interval on that exact estimate would have been. I don't have that off the top of my head.
Do you have any ideas how you would use this in larger teams? Because I'm guessing that over here, only like small teams can actually iterate through the number of possible structures.
Well, I mean, the how quickly you can try things out is, I think, separate from how big the team is. If you're in sort of like an environment where you're doing like rapid teaming, then I think you could do it quickly. But if you're in a situation where you're just trying to finish whatever your goal is, I think that's harder, right? Like you're just trying to launch the thing. Like, we don't have the time to deal with this right now, that kind of thing. I do think your direct question, how big of a team would it support? I don't exactly have a boundary condition for you. There are boundary conditions on how large any team should be. Like at some point you incur process loss. Like most teams are encouraged to be somewhere like in the under 10 size. And if you're larger than that, you should start splitting them up. And I feel relatively confident in that size. Like if you're trying to have 30 people all work together through this, I think it would just be much harder to enforce the norms, any shifts you're making. So I'll close with something where I tried to put myself out of a job. This was work led by Rajan Vaish, who's a postdoc at Stanford, along with several colleagues, including Serge Boulanghi at Cornell Tech, James Davis at UC Santa Cruz, Sharad Goel at Stanford. And as I continued to do this work, I was sort of increasingly of the opinion that, the research that I was doing was sort of very limited in the set of people who could be involved in it. And I saw this like super visibly when our department's in the middle of PhD applications right now. Basically, those who can attend the prestigious universities and get access to the research opportunities that basically all of us have had, it does have positive influence on their career outcomes. But it turns out that, not surprisingly, a lot of people can't do that. Pick your ranking. It all looks something like this, where the set of top of research universities and other institutions all cluster in the U.S., Europe, and a few other places, but you overlap a population map, and you start to see the problem where there's like some big differences. And from my point of view, this produces a research ecosystem that's underrepresenting the points of view of individuals in these regions. Like, we have a research literature that is itself biased and is not asking certain kinds of questions. So I started asking whether it would be possible to take some of the techniques that our field had developed over the last 10 years and apply it to help support upward access and mobility. Where participants would come together as essentially, I'll say here, sort of one large team, but as I might describe later, like it sort of splits up into lots of small teams that are coordinating to brainstorm, execute, and publish a project under the leadership of a PI, like someone in this room. Broadly, we wanted to support access to training and research experiences, and to ask what could happen if we had not like 3 people working on a research project together, but like hundreds, right? What could we do as a field if we all came together? You might be familiar with other kinds of crowdsourced research approaches, things like the Polymath Project or Foldit. They're really effective when this statement I made at the beginning of the talk is true, that you can sort of state the goal at the beginning and then we're going to push on that. So the Polymath Project had stated at the beginning what they were going to try to prove. Foldit basically says we're going to fold this protein. And then basically it's like all of the operators in some sense are known. But as even Gowers himself has written, research doesn't really work like that. I kind of wish sometimes that it did, but like we iterate. Things don't work, we try new stuff. So we didn't really, there did not exist a set of coordinating structures to support that. And again, the theme you can see here is that we're building more flexible structures. We had to solve 2 problems. One, how do we basically keep the project from moving in 1,000 directions at once when there are like 6,000 Slack messages each week? And the other is essentially one of credit. This matters here because in order to enable upward mobility, these people are eventually going to need to be able to prove that they made substantive contributions to the project. So we ended up developing sort of a pair of contributions here. One was effectively an iterative crowdsourcing technique that had a weekly cycle of open contribution, collaboration, and peer assessment. And the other was essentially decentralizing the credit allocation to the crowd itself to help identify the most impactful collaborators. So we launched 3 projects in this, and I'll unpack each of those contributions in a moment, but just to give some context, I led one that was building a new crowdsourcing platform that was hopefully more pro-social. James Davis and Serge Belangi were creating new forms of computer vision algorithms, and Sharad was essentially building out an experimental framework that would test the bounds of the wisdom of crowds. So like, why is it that we can guess the number of jelly beans in a jar, but not guess which direction the soccer kick is going to go? So for each of these projects, we followed essentially this process where we began with an open call. We would then have a group meeting, which is sort of like you would have with your interns or something like that, except there's a lot more interns. And this would lead to the articulation of a milestone, like some goal for the week that each individual or team or group would be trying to achieve individually or collectively. At the end of the week, they would submit this milestone. It would then go through essentially a peer assessment phase where people were upvoting, say, the ideas that they thought were interesting and so on. This would feed into the group meeting, and we'd iterate from there. So this ended up looking something like this, where projects went from anywhere from sort of like an internship to produce a poster, all the way out to like over a year or two to produce multiple papers, big Google Hangouts, gigantic Trello boards, code, prototypes, data analysis, writing. Peer assessment looked like this. It was sort of a little bit like Reddit, where people were submitting their milestones and then getting upvoted by others in the group. They had hangouts with people who are sort of well-known researchers, Andrew, Peter Norvig, Anant Agrawal, and so on, just to sort of get connected to this community. We had a lot of participants from India, I'll start by mentioning. But there were actually participants from 6 continents, still haven't quite managed to crack Antarctica. Most of them were, like the sort of modal participant would have been an undergraduate in India. China was small in part because they couldn't get onto the Hangouts. Also, I think more of a language issue, so we have to think about how to crack those issues, maybe by finding more diverse PIs. Just as an initial evaluation of how well we were able to bust out of the bubble a little bit, about 3/4 of these individuals came from, I'll say universities, but broadly affiliations that were ranked not very highly in the Times Higher Education Global Rankings. And we use that one because it's basically the only international one. And again, so question the exact number, but the rough order of magnitude seems about something I would stand behind. About 2/3 of them came from countries that were ranked worse than 50 in GDP per capita. So many of these people did not have access to research opportunities at their homes, as far as we could tell. They did produce some papers with massive author lists. Here's one, here's another one, and a few other works in progress. As I mentioned, some of the projects were intended to be shorter term. Just as, again, just sort of some quick checks, we compared the authors on these papers to all of the other papers at the same venues in which they appeared. You can see basically massive boosts in the percentage of those authors who were from affiliations that were, again, not ranked highly, or from countries that were that did not have high GDP per capita. It also shows some of the bias of our existing publication venues. In terms of attainment, I don't have like a control waitlist study to report here. We were mostly trying it out. Qualitatively, or maybe in a less controlled fashion, what I can say is that participants have gone on to many top graduate programs and undergraduate programs if they were high schoolers. About 2/3 of them were admitted to at least one program that they applied to using a recommendation letter from the program. But a median of them had 0 other letters from any sort of, again, well-ranked institution. So we have some sort of rough evidence that might have had an impact. Yeah?
Why are there only 33 people surveyed if there were like 1,500?
Not all of them continued with the project. So as with any sort of online collaboration, there's a huge spike of contribution in the first few weeks, but the papers would require essentially contribution at least over 10 weeks, or in some cases longer than that. And I think the people, so you can see the author lists were longer than 30. So not everyone who participated wanted a recommendation letter, But these were largely, this was about how large each one of these groups was by the time that they were finally submitting. So just like a MOOC or anything else, we did have drop off, although our retention rate was roughly twice that of a MOOC. So again, could have been novelty effects. So it's not like 1,500 people are all co-authors on papers now. I would say we're probably in the realm of about 100. So I mentioned that there were these recommendation letters, and the recommendation letters, one of the ways that they were able to sort of scale, so to speak, was to articulate who was having impact. And the PI can't have visibility into everyone's contributions here. So essentially, we democratized it back out to the set of contributors, where each individual, we gave them 100 points and said, you can divvy these points up amongst everyone else in the group in proportion to how much impact they have. So if Sid thinks that I deserve 15% of the credit, he can give me that. And we build out essentially a weighted directed graph out of this. Right? So we've taken something that's very fuzzy, like credit who deserves to be first author, and we turn it into something that we know a little bit more how to reason about, which is a weighted directed graph. You could, in principle, do anything from that you wanted. We went through for a graph centrality measure, and in particular, we used PageRank. Again, I think the exact approach you use at that point can be different, but the intuition behind PageRank, if you're not familiar with it, is that we're sort of iteratively identifying nodes that are sort of universally acclaimed. They get a lot more weight in the decision, and that percolates out and sort of runs until convergence. Yeah.
Do you think this can just feed in a lot of bias, where people see that someone's getting a lot of credit, and when they have to make a decision about who has to receive credit, they are inclined to say, oh, okay, this one possibly, because this already has received so much recognition from others, so maybe that's the most important.
Right, so two thoughts. One, if people can see the outcome as they're doing this, yeah, it becomes increasingly easy to basically be strategic about it. In practice, what we did is we would have a big open period where people could enter their scores. Then there was like a period in which we would show sort of roughly where it's at. So we would say, here's the current list. You have one more week to make any edits you desire. And then people could make any final edits. That was basically to just make sure people understood, weren't surprised by the final outcome. But if your deeper question is this strategy proof and incentive compatible? No. These systems are not strategy proof. And in fact, any of these kinds of things, like even used on the web, have had to mitigate all sorts of strategic behavior. In fact, blah, 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 there's a lot of strategic behavior. Link rings. What I would say is particularly what was of interest here was not that it could happen, but the ways in which it did happen. So in particular, for example, people were not being strategic necessarily with a malicious intent. There were some groups of people who didn't speak the same language as the other parts of the crowd, and they would have these basically cliques, more or less, which would sort of have the indirect effect of a link ring. Also, this can happen in 360 reviews. I don't know whether you all do 360 reviews here, but you can do this thing where you basically give more credit to someone who you think likes you, because then they'll give you more credit and try to amplify. There are formulations of these approaches that can minimize the effect of them, and I'll show some evidence that we can do this, but that's definitely an open question, and I think it's basically still an open question in much of in mechanism design as well. What I can say is that, and I'll show one example. When we surveyed people afterwards about their sort of point of view on whether this was effective or accurate, generally the answer was that they felt it was. They didn't feel that the Russians had manipulated it. Now everyone felt that they all should be higher. I guess my point of view is if everyone thinks they should be higher, then you're probably okay. So I think definitely this could have happened, and probably did happen in some cases. I'm much more interested in the ways in which this encodes other kinds of bias, which I'll get to in a moment. But yeah, it definitely could. Incidentally, if you want to play with it, credit.stanford.edu. I've been using it in some of my classes for the small team projects to make sure that everyone feels like they all contributed. We did do one analysis here, which is what impact this approach had on the credit distribution. And the way we analyzed this is that we basically had two DVs. So we had just the raw points. So if you sum up the points, divide it out, so just like a popular vote. And then you would have these credit-adjusted scores. So again, normalized the same way. So you have We then essentially regressed both that raw score and the credit score on all the observable features we have. So could be a bit of variable bias here and so on, just taking the things that we could observe. We then ran a statistical test to compare the beta estimates across those two regressions. So the way to read this is you can see what was statistically positively or negatively correlated with higher score in a particular approach. But what I would actually call attention to is what was statistically different between these two regressions. So this is saying, here's what's predictive of the credit score, here's what's predictive of the raw vote score, but that might not be interesting because both of them say that if you attended more meetings, it was positively correlated. Whereas if you actually compare them, it wasn't, at least at our sample or level of power, there wasn't like a huge difference. What was different between those was that essentially there were in the PageRank adjusted scores, there was less emphasis on talking. So compared to just taking raw votes, people who talked a lot in Slack got slightly less credit. And compared to just raw votes, people who were like leaders of these weekly milestones or were committing code got a boost. Now this could easily have turned out differently. It sort of depends on what the people who are universally acclaimed, how they were distributing credit. But essentially what we started to see was something wherein essentially people who were talking a lot in the community but not leading or either leading or contributing concrete artifacts were somewhat suppressed in the rankings. Just to give one example here, you can see one of the language-based cliques in the upper left here, where there was, by raw votes, that team of people who were all speaking a different language were all giving all their credit to essentially the person who was their team leader, who was second ranked there. Once you make the PageRank-based adjustment, it looked a little bit more like this, which this happened to be the project that I was helping PI. This looked intuitively a lot more realistic given the contributions that I saw. So is this a perfect system? Not at all. But is it a first shot at asking what it might look like if we sort of decentralize credit allocation? I think it's interesting. I do wonder what kind of impact a decentralized credit approach might have on traditional teams or organizations. It would certainly decentralize the things. A lot of things are wrapped up in performance review and so on. But more broadly, I still wonder what kinds of research projects could we do if we really thought about like what happens if like 10, 20, 100 of us all work together on something. HCI I often describe as a problem setting field, which means that sometimes it's hard to get a bunch of us all working together on one project, as opposed to being problem solving. But I do sort of remain interested in that. I'll close with two observations. If I make any point here, it's that rather than structuring that future of work essentially as algorithm, I think that increasingly, the real transformational change is going to happen if we start to develop essentially computationally augmented organizational structures. What does that look like? How do we support membership, process, and structure? And I'll close with a historical note, which is that organizations are not as old as we think. They came up in the Industrial Revolution, so like a couple hundred years old, basically. And they came up with the rise of the railroad. Because different cities needed to coordinate arrival times, like they needed to develop a schedule. And at the time that they were developing this, they looked around at the most advanced technological metaphor they could come up with, which at the time was literal physical mechanisms. So if you look at the writing as of the rise of the organization, they were saying things like, we want people to interact as effectively and efficiently as like gears interlocking. And this became the entire metaphor through which hierarchical bureaucracy was developed. And my question is, if we step back and start designing organizational structures or organizations from a computational metaphor, something that's data-driven, adaptive, and so on, where are we going to end up? I think it might look substantially different. And this is the kind of question that's continuing to animate me. So with that, I just want to thank some awesome students who I have the privilege of working with at Stanford, colleagues who I was able to collaborate with on this work, supporters, and you all for amazing questions. Thanks.
Time for a few more general questions.
Yeah, Jonathan.
So you alluded briefly at the beginning to possible effects of computational augmentation on happiness, and I just wondered if you had more thoughts of that, which also applies to thoughts about hierarchical bureaucracy.
Yeah, so Social computing design, any system you build is going to be an instrument of power, in that it's going to make some people better off, some people worse off. Doesn't matter whether you're talking about wikis, Facebook, bureaucracy, anything, right? It's regardless of how we want to do it, it's going to have some impact. And I think for me, the question that I ask is, how do we make those trade-offs, right? We're now in a world where I think in many cases it does not make sense to argue for sort of unequivocal good in the things that we're creating. And I think we have to acknowledge the sort of negative trade-offs and make, through whatever moral framework that we can borrow from, like from philosophy or elsewhere, make those decisions. Deontologically, I think it might be feasible to argue that, any such system that we deploy needs to have, essentially the human happiness as one of the outcomes that matters, at least at co-equal status with whatever, say, performance you care about. I'm sort of I don't think we have the structures for enforcing that. One thing I really struggled with, I sort of was gesticulating, we were creating a crowdsourcing platform that was intended to be more pro-social, but also open source. And I spoke with someone who had built a crowdsourcing platform that was intended to be pro-social and open source, and guess what happened? It was open source, so a company took it, stripped out all the pro-social elements, and then basically deployed it to exploit their workers. And I don't think we have things like an open source license that has clauses in it that can enforce the kinds of things you can and cannot do with it. I don't think as technologists we've really built the structures to support that. And I think even as researchers, I'm seeing a lot of debates about this, and I think that we need to develop, maybe we at least are small enough as a community to develop a set of norms. And at least that's what I'm trying to do, is at least think for myself, how do we trade those things off? Ultimately, especially given that we can't always predict, right? There's this great paper from a sociologist named Merton in the 1930s, where the entire title of the paper is "On the Unintended Consequences of Purposeful Social Action," which I basically translate as social computing designers try to get A but get B instead. It's like we can't predict second order and third order effects and so on. And I think if we treat that as fundamentally unknowable, then it puts us in sort of a weird bind as a design discipline. But same thing with architects, urban planners, and so on. So I feel like there's a lot we can draw on. I wish I had an answer. Yeah, Helen.
Sort of related to that last question. Thinking about the Flash organization's work, it seems like in traditional organizations, people on kind of the bottom of the hierarchy are not encouraged to think holistically about how the system works.
Yeah.
And so this potentially flipped that, and I'm curious to see, how often did it happen that people at those lower levels were submitting pull requests to change the structure? Mm-hmm. And what did that look like? And then, I can hypothesize about various effects that would have. One is, maybe that's very empowering to know that you have this, agency to change the structure and to see problems and fix them. Mm-hmm. And maybe it is scary in that, my peer can decide that they want to take over this part, and I don't have a say in that.
Right. If you asked one quantitative question, which is essentially boils down to what proportion of the pull requests came from down in the hierarchy, and I would say the vast majority came from pretty low, either the sort of team leads or the team members, but that, in some sense, isn't surprising because they're managing their sort of local stuff. The real question is, how often did something percolate up? So we have examples of it. For example, in the medical EMT one, there's someone who was tasked with designing the website realized that essentially there was something that was sort of completely missed by, let's call it the product team, that they then sort of pitched back over, and there was a discussion, and they ended up reevaluating. But I do suspect that the longer these organizations last, the more the power structures will ossify, and thus it would become harder, and you might start getting pull requests denied and so on. I think people will navigate within the constraints of the technology to essentially pursue their interests. So I'm not so idealistic that I think this would fundamentally lead to some sort of sea change. It might increase visibility. It might create some short-term opportunities. And I think the question is much more actually, like, I'm a big believer at this point in norms. How do you develop the norms, and how do we design the norms into the system that make it reasonable for that to happen, right? That expects that you should be doing that and that it's welcomed and all this kind of stuff. That, I think, is the long-term win, but also a very indirect goal. So hard to directly design for. Yeah.
The third project, I find the vision absolutely compelling, broadening the access to research. I'm curious, how many of those students could be fruitful members of the reviewing community and things like that? I feel like there's like only a small bit which goes to paper writing and being part of a research project. There's a lot more that you need to learn. And so it seems like, the 30 odd people who end up going to the top PhD programs are the ones who are on that path. And all this has done is maybe just given an epsilon chance of them getting admitted as opposed to actually truly broadening access to research.
Yeah, speaking in my role as the WIST program chair for this year, yeah. I mean, I don't think, I think the answer to, all the questions about pipeline problems is always yes. I think if you want to broaden that, the way to do it is to get more people into the system so that they can get mentored into the point where they become, say, PhD students and so on. I do not think that Kai might sometimes do this, but I do not believe that someone who has written a single paper, is necessarily fully ready to, review generally in HCI. I think with some mentorship they can and so on. But so I think it's much more about what do we do following that point. Yeah, I mean, I was playing with some crowdsourcing techniques that would allow, for WIST, we were playing with this technique that would allow essentially a first pass of review that would try to sort of remove the, say, bottom third of submissions that never really stood a chance through like PhD, like a grad PC. But it turned out we would have needed like 80 members to do that to a level in which like we were confident in the decisions, and that didn't seem sustainable. So my point of view is, if you want to control review load, it probably has to be done at an editorial level before things go out to full review. That's a hard decision to take. Different people have different mental models for it. Some people believe that review is essentially, like the metaphor is judicial, like everyone gets a fair trial, and for other people it's a decision process, and the only point is to select the good work. And what I found, at least in my role as PC chair, is that those points of view come into conflict, right?
This system basically helps train this class of inexperienced reviewers, because they can like sort of learn from their peers and sort of upload good reviews or things like that.
It could, yes. I feel like it's, I feel like that's probably not the carrot I dangle. Like, you could be a reviewer if you only do this. I do think that, for many of the individuals, what really mattered to them was the upward, the upward educational and career opportunities. I think it would be interesting to ask, could we maybe not get the individuals to review, but could we have the group, collectively follow some process to review? That wouldn't hit the same scale you're interested in. I guess I think what I'm saying is I'm not sure that this would directly solve the problem you're aiming for. I do think it would increase the pipeline, but increasing the pipeline also increases the number of paper submissions, so it increases the load. Yeah, Shamsi.
Yeah, somewhat related. So for the third project, it seems that there is a strong cultural component to it. Mm-hmm. So because you're drawing people from all over the world.
Yes.
And did you do anything to reconcile those differences? For example, if I look at the coefficients and I saw that, well, GitHub submits, and whether or not you were at a leadership position and whether you participated in Slack, yeah. I'm guessing that they might not all be the same group of people. So people who have language barriers, for example, they might be more in the GitHub submit category. And is there a way that you could encourage people to move across or try to develop the other skills, or even make it available that, okay, these are the factors that seem to have the most effect?
Yeah, what we observed was that people would self-select into teams. So what was kind of crazy about the development on this project, which is largely halted at this point, was that people would self-select into like doing UX research or front-end development, back-end development, data science on the data from the platform. Basically, they found a way in which they could connect, and often that was, I think, that might have had some correlation with their cultural background or their educational experience. So a lot of the people, for example, who didn't have programming backgrounds ended up doing UX stuff. And, is that correlational or causal? Like, I do think maybe more, equally importantly, we did see some instances where there were cultural norms coming into conflict, and there was essentially a storming phase wherein that group had to develop some cultural norms about what was okay to say and do, like especially around how aggressive critique could be. And I, at least in my project as a PI, was very, tried hard to make sure that there was not aggressive, a culture of aggressive critique. But that's my own cultural point of view. I think that ultimately the solution probably is to do more projects with a more diverse set of PIs so that you can get sort of more of a micro-local kind of approach. Because ultimately there was a lot of variation in how the PIs ran the projects. I think Sharad, for example, was much more hands-off and sort of just let things go.
I think one last short question. You have lunch with me. You don't get that. Okay. I think let's thank Michael again for a fabulous talk.